Hello, I'm your TA. In this video, I'm going to share you how to do handy calculation for ANOVA with examples, and I will show you also how to do ANOVA in SPSS. We need to know three assumptions for ANOVA: equal variance, linearity, and normality. I'm going to show you a formula for ANOVA table with examples. We want to test the mean of SAT score is equal across three teaching methods. So group 1 is taught by teaching method 1, group 2 is taught by teaching method 2, group 3 is taught by teaching method 3. And my first examinee is denoted X11. First group, second examinee is denoted X12, X13, X14. My second group, first examinee is taught by 2-1. Second group, second test taker. Second group, third subject. Second group, fourth subject. Third group, first subject. Third group, second subject. Third group, third subject. Third group, fourth subject. And I will write group mean as X1 bar, X2 bar, X3 bar. And I will denote grand mean as X dot dot bar. Since we want to test mean of SAT score is equal across three teaching methods, which is three groups. So I will set my null hypothesis as mu over group 1, mu over group 2, mu over group 3 versus H1 can be at least one population mean of SAT is different. And I will write K as the number of a group. So K is start from 1. K is number of groups. And my N is 1 is number of subjects in each group. So sum of square treatment can be written as J is 1 to K and number of subjects in each group times group mean minus grand mean. So we can write as, because we have 4 subjects in each group, so 4 times first group mean minus grand mean squared. Second group, there are 4 subjects. Second group mean minus grand mean. There are 4 subjects in third group, x3 bar minus x dot dot bar squared. And sum of square error can be written as number of groups, number of examinees, and xij minus each group mean squared. Since sum of square treatment plus sum of square error is equal to sum of square total, I will show you how to calculate the sum of square total, and then I will do some algebra things to calculate the sum of square error. So formula for the sum of square total is number of subjects, number of groups, and SAT score for everyone minus x dot dot bar squared. So I can write this one as x11 minus x dot dot bar squared. First group, first subject. First group, second subject minus grand mean. First group, third subject minus grand mean. First group, fourth subject I can write in this way because SS treatment plus SS total, SS adder is SS total. To calculate the sum of square adder, I need to calculate SS total minus SS treatment. So I can rewrite sum of square adder as sum of square total minus sum of square treatment. And then degrees of freedom of treatment is number of group minus 1. And degrees of freedom of error is number of group times number of subject minus 1. And degrees of freedom of total is number of group times number of subject in each group minus 1. Degrees of freedom is also degrees of freedom of treatment plus degrees of freedom of error is equal to degrees of freedom of total. And mean square is sum of square treatment divided by degrees of freedom of treatment. So I can rewrite as k minus 1. And mean square of error is sum of square of error minus divided by degrees of freedom of error. So I can rewrite degrees of freedom of error as k and minus 1. And f value is mean square treatment divided by mean square error. I need to compare this f value to my f critical value. So I need to let you know the critical value first. So critical value, if my alpha is 0.05, for example, my degrees of freedom consists of two parts. So first part is from my numerator. So mean square treatment degree of freedom is k minus 1. So k minus 1. And degrees of freedom of the second part is degrees of freedom of mean square error, which is k and minus 1. So k times n minus 1. So I'm gonna show you with examples. So group mean, for example, is 9, 8, 6, 8. Group 2 is 7, 9, 6, 6, 11, 13, 8, and 6. So my first group mean is 7.75. Second group mean is 7. Third group mean is 9.5. My grand mean is 8.08. So I need to calculate the sum of square treatment first. So there are 4 subjects. First group mean is 7.75 minus grand mean is 8.08 squared. Second group consists of 4 test takers. 4 times 7 minus 8.08 squared. 4 times 9.5 minus 8.08 squared. If I calculate it, my answer is 13.17. Rather than calculate the sum of square error, I'm going to calculate the sum of square total first. So I will erase this part, and then I will write from first group, first subject. So 9 minus 8.08 squared. Second one is 8 minus 8.08 squared plus first group third examinee is 6.8.08 squared plus first group fourth test score is 8 minus 8.08 squared plus, so the last one is 6 minus 8.08 squared. So if I calculate it, my answer is 52.92. And then let's calculate the degrees of freedom. So number of group is 3. So 3 minus 1 is 2. My number of group is 3. My n is 4 minus 1. 3 times 3 is 9. And my group of number is 3 times 4 minus 1 is 11. So 2 plus 9 is equal to 11. And mean square of treatment is sum of square treatment, which is 13.17 divided by degrees of freedom is 2, which is 6.58. And sum of square error is 52.92 minus 13.17, which is 39.75. So 39.75 divided by 9 is 4.42. So my F value is mean square treatment 6.58 divided by 4.42, which is 1.49. So for making a decision, I need to compare critical value. So in page 692, alpha is 0.05 and my degree of freedom is 2,9, which is 4.26. So I need to compare F observed value to F critical value. Since this is my F distribution, this is my critical value, which is 4.26. After this line, I need to reject the null hypothesis. However, my observed value, which is 1.49, which is F observed value, so I failed to reject the null hypothesis. So I can say mean of SAT score is equal across 3 teaching methods. And I'm gonna show you how to do this one in SPSS. This is SPSS. So group 1 consists of 4, group 2 consists of 4 subjects, group 3 consists of 4 subjects. So analyze, compare means one-way ANOVA. So dependent variable is SAT score and factor is a group, just in case options. And let's check the homogeneity variance of test. And then okay. And then I need this ANOVA table. This is my result and I got all the same value. And this is my p-value compared to my alpha 0.05. my p-value 0.276 is greater than my alpha, which is 0.05, I failed to reject the null hypothesis, and I could say I got a same result. Thank you for watching this video, and if you have any questions, please reach out to me.